Okay, in this video, I'll show two more examples of how to solve linear equations. Um, just as a reminder, linear equations look as follows. dx dy plus p of x times y equals q of x. That's the standard form of linear equations. So in example 2, we have to find a general solution to 1 over x times dy dx minus 2y over x squared equals x cosine x. Our first step is to write the equation in standard form. So the main thing about standard form is that we have a leading coefficient of 1. There's a 1 in front of that dy dx, and here we have 1 over x. So what we're going to do is we're going to multiply both sides of this equation times x. So I'm going to write x times, and then I have 1 over x dy dx minus 2y over x squared, and that equals x cosine x. And then we have to multiply that by x on the right hand side as well. Okay, and when we do that, we then get the following. The x's cancel, and so we have dy dx minus, and then 1x here cancels, and we still have a minus 2 over x minus 2 over x times y. And that's a 2. And then on the right hand side, we have equals x squared cosine x. And so if we compare that with our standard form, we can see that p of x is negative 2 over x, and then q of x is equal to x squared cosine x. Okay, and our second step is we want to find the integrating factor. So step 2 is find mu of x equals e to the power antiderivative of p of x dx. Okay, so let's do that here. We have e to the power antiderivative, and we saw that p of x was minus 2x minus 2 over x. And when we find the antiderivative of negative 2 over x, we find that that is minus 2 ln of x. In order to simplify that, we cannot just cross out the e and the ln. We have to get rid of that -2. So what we're going to do with that -2 is we're going to move it inside the natural log. And then what we get is we get e to the power ln of x to the power -2, which is 1 over x squared. And we don't have to worry about the absolute value anymore now because we have an even power. And so the e and the ln cancel out now. And so our integrating factor, mu of x, is 1 over x squared. So let's summarize that here, that mu of x is 1 over x squared. Okay, and then the third step is we're going to use that formula from the previous page. Y of x equals 1 over mu of x times the antiderivative of mu of x q of x dx plus a constant of integration. Okay, so let's do that. So we have y of x equals 1 over, and then our integrating factor is 1 over x squared, and then multiply that by the antiderivative of 1 over x squared times q of x, which was x squared cosine x. And then we have our constant c. Okay, 1 over x squared. Let's write that out as follows. It's fractions in fractions. That's 1 divided by 1 over x squared. And then what you'll see in the next step, we'll flip that fraction and we get x squared over 1. So there's just an x squared in front. And then when you look at the integral, the x squared and x squared, they cancel. And so we're just left with the antiderivative of cosine x dx. And then plus a constant of integration. So 1 divided by 1 over x squared, multiply times the reciprocal, we get x squared. And then antiderivative of cosine is sine of x plus that constant of integration. And then the final step that we have to take is to distribute that x squared. So that's x times sine of x plus c times x squared. And that's our final answer. Okay, let's do another example. We have a differential equation here dy dt plus 2 times y equals 50 times e to the power negative 10t with an initial condition y at 0 equals 40. So let's focus on solving that differential equation first. That will give us a constant, and we'll find that with the initial condition. So we're going to go through the same 3 steps. We're going to write it in standard form. We're going to find the integrating factor, and then we're going to plug it all into this equation here. So standard form, our differential equation is already in standard form. So that's easy. And we can see from the standard notation that p of x, the function in front of y, and in this case, it's actually p of t, because our independent variable is t. So we see that p of t is 2, and then q of t on the right is 50 e to the power negative 10t. Second step is we're going to find our integrating factor mu t equals e to the power antiderivative of p of t dt. So we find that mu of t equals e to the power 2 dt. Our function p of t is the constant function 2. Oops. And the antiderivative of the constant 2 is just 2t. And so that's e to the power 2t. And that's our integrating factor. So we find mu of t equals e to the power 2t. Remember, we don't worry about any constant of integration here because we want one function that works. And the easiest choice here is c equals 0. So now we have our integrating factor mu of t equals e to the power 2t. And our third step is we're going to plug that into our formula. Y of t equals 1 over mu of t times antiderivative of mu of t times q of t dt plus a constant of integration here. Okay, so let's do that. We get y of t get y of t equals 1 over mu of t, and that's e to the power 2t. And then we're going to multiply that by the antiderivative of mu, which is e to the power 2t times 50 e to the power negative 10t. And then we add our constant of integration. Okay, so 1 over e to the power 2t, we can write that as e to the power negative 2t. And then our integral here, we can simplify this as follows, because we can use rule for exponents that when you multiply the exponents, you add the exponents here. So 2t plus negative 10t gives us negative 8t dt plus a constant of integration. Now, you may need to do this with a substitution, but in the interest of time, I will just give you the antiderivative here. So the antiderivative will be 50 over negative 8 times e to the power negative 8t, and then plus a constant of integration. Okay, and if you don't believe me, you can of course always take the derivative of this, and the chain rule tells you that you have to multiply by negative 8, and so that negative 8 cancels out, and then the derivative of e to the power t is just e to the power t, or in this case e to the power negative 8t derivative of that is negative 8 times e to the power negative 8t. Okay, and let's simplify that and put it all together. So e to the power negative 2t times e to the power negative 8t, we add the exponents, and we then get negative 25 over 4 times e to the power negative 10t plus c times e to the power negative 2t. Now, we're almost done here, so this gives us the general solution, but we still have to use the initial condition to figure out what c is. So that's an extra step here. So let's make that step 4. Find c. And so we know that y of 0 equals 40. Y of 0 equals 40. And then let's plug that into the solution we have here. So we have y of 0, right? That's negative 25 over 4 times e to the power negative 10 times 0 plus c times e to the power negative 2 times 0. Okay, and on the right, we get e to the power 0 is 1, so we get negative 25 over 4 plus c times 1. And on the left, y of 0, we saw that that was 40. And then if you solve that for c, you add 25 over 4 on both sides. And then your final answer for c is 185 over 4 equals c. And that makes our final solution y of t equals negative 25 over 4 e to the power negative 10t plus 185 over 4 e to the power negative 2t. And that's our final answer.